The modern periodic table that Henry Moseley gave consists of groups and periods. Now, what made him arrange them in that order? So let us take one group and let us see the pattern. And that's how we can learn the trends in the properties of those elements. Now, the motive was to arrange the elements in such a way that element in one group should have same chemical and physical properties. And as we know, electronic distribution or the atomic number was the fundamental quantity for that. So let us see the electronic distribution of elements in one group and let us see how we can justify that chemical and physical properties will be same for all the elements in one group. So I'll take first group. So here are the elements of group 1 and here are their atomic numbers. Now we are going to see the electronic distribution and find the pattern. So this will have 1 electron in the first shell. And here for lithium, atomic number 3, the distribution will be 2, 1. Because maximum K can have 2 and L will have 1. Again, 2, 8, 1, 2, 8, that is 10, again 8 and 1. Now you need to practice writing the electronic configuration of at least elements from atomic number 1 to 20. 2, 8, 8, 18 and 1. 2, 8, 8, 18, 18 and 1. If you add these, you will get 55. That is the atomic number. Now, can you find a trend? Of course you can. The first thing that you observe is that the number of shells increase by 1 in successive groups. So you can see that as you come one step down, you can see that one more shell is being added. So down the group, the number of shell increases. Second thing you can find is, if you remember what is valency, all of them need to lose 1 electron to become stable or to attain octet. That means their valency is same. That is, the number of electron in the outermost shell is same for all of them. As you can see, the number of shell increases down the group. The atomic size or the atomic radius increases down the group. Now note down that here we are talking about groups. So these are the trends only in a group. The number of shell is increasing down the group. Valency is remaining the same. Of course, the shell is increasing, so the atomic size also increases down the group. Now, the next property that we are going to see is the metallic nature. Now, what we know is that in group 1, all of them are metals. Of course, hydrogen is a non-metal, and only because of its electronic distribution being similar to elements of group 1, it has been placed with them. So for lithium and potassium, one thing that is common is that they have to lose this outermost 1 electron to become stable. Now tell me, for which of these two it is easier to remove this electron? Of course, it is for potassium. Now you'll ask me the reason, and the reason is so potassium can easily lose this 1 electron because this electron is farthest from the nucleus. Now you will understand this from the basic structure of atom. Atom has proton in the center and electrons are distributed in the shell. Now of course for this element it is easier to lose this electron because it is farther from the proton and because there is electronic force of attraction between electrons and protons. And so this electron will be more attracted to this proton and it will be easier for this element to lose the electron which is farther away from its center. And so we'll say that potassium is a better metal than lithium because it can easily lose this 1 electron. Of course, this will also lose 1 electron, but it will require more energy. While Potassium can lose it easily. And so, what happens to the metallic nature down the group? It increases. So, metallic nature increases down the group. And the reason is that size increases down the group, and so it is easier for the element to lose its outermost electron. Now, one thing to note down is that this part of trends is the most important part for your exams. The frequently asked questions that you see are, they'll ask you the trends in groups and periods. They'll ask you the reasons for the trends, or they can ask you to arrange the elements in one of these trends. That means they can ask you to arrange these elements in their increasing or decreasing order of atomic size. Or they can ask you the trend in the metallic property. They can ask you its reason, or they can give you a number of, for example, they give you a list of these elements and ask you to arrange them in increasing order of metallic nature. So these are the questions that can be formed from this part.
If you like the video, please hit the like button, comment and share it with your friends. Also, don't forget to subscribe for all our future videos.